Okay, so the last session we discussed about uh, light emitting diodes, especially. Okay, so we just discussed about the various unit contents. Okay, LEDs, LCDs, photoconductive cells, photodiodes, solar cells, Schottky barrier diodes, varactor diodes, power diodes, then the tunnel diodes, IR emitters, and the thermistors. So these are all the unit contents. The last session we did an exhaustive study about the principle and the working of light emitting diodes. Okay, so these were the contents which we had discussed in our previous session. We had also discussed about the concepts of the direct band gap semiconductor and the indirect band gap semiconductor. Okay, so usually the semiconductors which possess indirect band gap do not emit light, whereas the semiconductors, especially the compound semiconductors like gallium arsenide, gallium nitride, gallium arsenic phosphide, they possess direct band gap, so that during the recombination process they have the ability to emit light of a specific wavelength. Okay, so just by fine tuning the band gap we can obtain different wavelengths, in the sense different colored light emitting diodes. Okay, so that's the generation and the recombination process. Okay, and we had looked at this slide that the green color is extremely sensitive. Okay, especially at a wavelength of around 550 nanometers.
Excuse
The
me, sir.
response to the yes.
Sir, some of them are still trying to join.
Okay, all right. Okay, so those were the general purpose applications of light emitting diodes. So today we shall be discussing about one more display device which is called as liquid crystal display. These devices have also gained a lot of popularity because of their low power advantage when compared to the light emitting diodes. Okay, so we'll just try to focus on some of the important aspects of LCDs when compared to LEDs. We'll try to discuss some of its advantages and also drawbacks. Fine. Okay, so LCD stands for liquid crystal display. These have many advantages over LEDs. The main advantage of a liquid crystal display over an LED is its ability of consuming low power, okay, which means LCDs consume less power when compared to LEDs. Just to compare them, if an LCD consumes the power in terms of microwatts, then a LED consumes the power in terms of milliwatts. So you can just compare LEDs with respect to LCDs only in terms of the power consumption. However, although LCDs consume low power, they have some one or two main drawbacks when compared to LEDs. Like LCDs require an external or internal light source. Okay, that means they require an additional external or an internal light source, unlike a LED case. Okay, LED just due to the recombination process within the semiconductors, if they are of direct band gap, then they can directly emit the light. They don't require any external light sources. However, LCDs do require external light source. So that is one major drawback. Then they also have a temperature limitation, especially like they have a temperature range of about 0 degrees Celsius to 60 degrees Celsius. So for extremely high temperature applications they may not be so useful. Similarly, for extremely low temperatures below 0 degrees Celsius they may not be of so use. Okay, so it all depends on what kind of application does the display device require. Okay. Then there is a major drawback, one more major drawback associated with respect to LCDs, that is its lifetime. Okay. Lifetime is a major area of concern because LCDs chemically degrade over a longer period of time. Okay. Just to give you one simple example, okay, your LCD displays, if they are of when they are just newly brought, their brightness will be very sharp, but over a period of time, maybe after 2 years, 3 years, you will just notice that their brightness level has got reduced. Okay, because they slowly degrade, okay, because of their chemical reactions. Further, we will be focusing on two types of LCDs. The first one is field effect and the second one is dynamic scattering unit. Okay, in field effect we have two types. One is transmissive type and the second one is reflective type. Okay, so let us just focus on the first one, which is dynamic scattering. Okay, there is another word associated with these things. We usually the word pneumatic. Okay, all right. So this is the first type of LCD. Okay, so that's the construction of a pneumatic liquid crystal. Okay, so we'll try to understand it with respect to two cases. In the first case, when there is no externally applied bias, and in the second case, when external bias is applied, how does it work? Okay, but before that, let us first understand the construction. Okay, what are the various layers present within this crystal unit. Okay, so you can just assume this entire square box to be one crystal unit. So what do we have here? The structure shows that there is one upper glass layer and one lower glass layer. Okay, so when we say glass, they are transparent. Within these two glass layers, a liquid crystal organic material is being embedded. So this sky blue colored region indicates a liquid crystal. Within the liquid crystals, we have these oval shaped rod structured molecules. Okay, so these are always present within the crystals. Now this is although it is mentioned as liquid, it is not completely liquid. It appears to be liquid, but it has the properties of a solid. What does that mean? That means this is this liquid is some sort of jelly material, jelly organic material, jelly organic material. Okay, so normally almost all the jelly organic materials, they possess rod kind of molecular structures within them. Okay, so these all rod kind of white colored oval shaped structures indicate those cylindrical rod kind of structures. Fine. If we just take this is the cross sectional view. If we take the other angle view, then it appears like this. Okay, so that's the oval colored rod kind of molecular structure, and if we take this kind of view, okay, then it appears like this. So these are cylindrical shaped structures, okay, which make up this jelly kind of material. Now this black colored layer at the top as well as the bottom is a layer of indium oxide. Okay, although it's an oxide, it becomes conductive whenever any external bias is applied. Okay, so it is very clearly mentioned that it's a conductive clear coating. Okay, fine. And at the left hand side and at the right hand side we have spacers which ensure that the entire structure is completely vacuum sealed. Okay, fine. So initially when there is no external voltage being applied, when V is equal to 0 volts, what happens whenever any incident light falls on this particular structure? Okay, see, the first point to be remembered here is that unlike LEDs, LCDs don't have any internal light source. Okay, so this is an external incident light. Okay, fine. Alright, so whenever any external light is made to fall on this particular structure, the glass is transparent, so the light just crosses it. Then the jelly material is also almost translucent. Okay, so light will very easily pass through it, and then again it falls on the bottom glass material, so there is absolutely no blockage in the light, and then light can easily pass through it. Okay, so that means whatever light falls here, the same light crosses. Okay, but what happens here also, because external voltage is 0, you will assume that there is absolutely no change in the orientation of these rod molecular structures. They are almost oriented in the same direction. Okay, so they are not doing any harm to these light rays. Okay, so even under the clear region and even under the region where we have the conductors, the light easily passes, so there is absolutely no problem. However, this is of no purpose for us. Okay, what happens when we apply external bias? Okay, so please observe within the structure, whenever light is being applied, whenever external voltage is being applied, electric field gets established only within this region. Okay, why? Because we have conductive clear coating regions. Okay, so electric field gets established. Due to the established electric fields, these rod kind of structures, they change their position, their orientation gets completely changed. Okay, so we call it as dynamic change. Instantaneously their positions get changed. So when that happens, whatever light falls, okay, when it falls on these particular molecules, the molecules have the ability to reflect and refract the light. I repeat, these disoriented molecules, they have the ability to reflect plus refract. Okay, I hope all the students know the meaning of reflection and refraction. Okay, now the point is, light gets completely reflected and refracted, and it just keeps on propagating within the structure itself. Okay, the point is, light never crosses this region. No. So to put it in other words, this region is called as frosted region. Okay, what does frosted mean? Trapped. Okay, and what gets trapped here? Light gets trapped for a moment of time. Okay, for a short period of time. So call it as trapping of light. Okay, so when light gets trapped, this region for human eye, okay, if I just say this is the human eye, okay, for human eye, if the viewing angle is from this end, then this entire region appears to be dark because light is not coming out. Okay, whereas this clear region appears to be lightened. Okay, so what does that mean? In a single unit, some region is appearing completely bright because light is getting passed, whereas the other region where the light is getting trapped, it appears to be dark. Okay, so now there is a display of dark and light. Yes, okay. So this or such kind of phenomena can be controlled by varying the external bias. Okay, for example, if the external bias is 2 volts, then the trapping of light will be different. If it is 5 volts, then it will be different. If it is 10 volts, then it will be different. Okay, so it all depends on externally applied bias. Okay, the ability of the frosted region, okay, the range of the frosted region can be controlled with respect to the externally applied bias. Okay, so the theory explains the same thing. You can just go through the theory content at your leisure time. So that was all about nematic liquid crystal. Okay, the point is, without any externally applied bias, the molecules will be in their stable state or natural state. Whenever any external bias is applied, they get completely disoriented, due to which whatever light falls on them gets reflected, refracted, and it just keeps on moving within the crystal structure and gets trapped, so that the display appears to be dark. Okay, fine. All right, so we will move forward and try to understand another type of modified LCD, modified nematic LCD, which is called as twisted nematic LCD or field effect LCD. Okay, so let us try to understand that with respect to its construction. So what does the construction all say about? Well, it's a rectangular kind of a structure which comprises of various layers. So we'll try to understand the significance of each and every layer. At the outer side, left hand and the right hand side, we have 2 vertical light polarizers. Okay, now what do you mean by polarization? Polarization is a phenomena associated with respect to light. Okay, if we are trying to extract the various components of the light, then we call it as polarization. Okay, for example, light always consists of vertical component and the horizontal component, Okay, using some methodology, if we are able to extract only the vertical component and reject the horizontal component, we call it as a vertical light polarizer. Okay, so such kind of a layer is being applied to this particular structure at the left hand side and the right hand side. So this black colored layer indicates vertical light polarizer. Then attached to these vertical polarizers, we have 2 layers of glass on either side. Okay, left hand side as well as right hand side. So this region is glass. Then internally, again we have 2 conductive surfaces, clear conductive surfaces, to which we apply external bias. So as of now, let us assume that there is no bias. Okay, fine. Now how does this particular structure work? This blue colored region indicates the crystal. Okay, so that's the liquid crystal, similar to the one which we had discussed. But there is a small change here, and that small change is the nematic LCD is twisted during the manufacturing stage itself. Twisted in the sense, what does that mean? By applying some external force or field, it is ensured that these crystals, these rod kind of molecules, they are not aligned, they are disaligned or misaligned. Okay, so hope you can just observe here. that these molecules are not aligned. Okay, such kind of a molecule indicates a horizontal rod, and this is a vertical rod. Okay, so when you move from right hand side to the left hand side, you can observe that there is a 90-degree phase shift. I'll just write, there is a 90-degree phase shift in the orientation of these rod structured molecules. So there is a phase shift of 90 degrees in the structure itself. So during the fabrication itself, it undergoes a twisting. Now, what happens whenever light is being incident here? Okay, so when light falls on the black colored layer, which is a vertical light polarizer, the polarizer ensures that only the vertical components of light will be passed, whereas the horizontal components will be blocked. Okay, so you can very clearly observe here, it is only the vertical component of the light which is being allowed to pass. Okay, now these layers are just transparent, so the same light enters. Okay, so this is the vertical component of the light which has reached the crystal region, the liquid crystal region. Okay, and since the molecule is vertical, okay, so this has no effect on the vertical component of the light. However, this rod is slightly twisted, so whenever light falls on it, the light component also undergoes reflection or refraction. Okay, similarly, this particular molecule is further twisted, so the light component gets twisted further. So what happens during the consequence is that whenever the light component reaches here, it gets completely shifted by 90 degrees. So instead of vertical, it becomes a horizontal component. Horizontal in the sense, light is within the screen now. Okay, hope you can understand, right? Okay, so what has happened? The vertical component of light has become horizontal component due to these rod kind of molecules. Okay, so eventually what happens when the same horizontal component moves here and falls on the vertical light polarizer? Okay, please understand, this is also a vertical light polarizer. So when horizontal light component falls on vertical light polarizer, the vertical light polarizer blocks all the horizontal light components so that nothing appears here. Okay, there is absolutely no light coming out of this which falls on the human eye. So the result is the entire unit appears to be dark, which you can correlate here. Complete display appears to be dark when during no bias case. No bias. Okay, now let us apply some bias. Okay, maybe 2 volts, 3 volts, like this. So what happens whenever any external bias is applied? Due to the applied bias, these crystals, the molecules within the crystal, they undergo a positional change. They get aligned. In what way? They get aligned like this. Initially they were all disoriented, but due to the applied field, they become perfectly aligned. So when they become perfectly aligned, the vertical light component, okay, is not at all affected by these molecules. So it will just pass, and at the left hand side I will be getting the vertical component itself. And a vertical light polarizer, it easily passes the vertical components so that the human eye can see the light. Light just passes, crosses over and falls on the human eye. Okay, so due to this, wherever the light falls, that particular portion of the display appears to be illuminated. Okay, so this is due to light. And when? This is during applied bias. I hope this concept is clear to you, students. Okay, please understand, the incident light without any application of bias gets shifted by 90 degrees and becomes horizontal component, and the horizontal components gets blocked at the vertical light polarizer, due to which no light comes out. Okay, and however, whenever external bias is applied, the molecules itself orient themselves, align themselves parallelly, so that the vertical component is not at all blocked. There is no conversion from vertical to horizontal component of light. Okay, so that the entire light will be allowed to pass. Okay, you can very clearly observe here, horizontal polarization cannot get through the vertical polarizer. Okay, so due to which the dark region appears. Whenever light crosses, we will be getting the illuminated or the lighted version. I hope this principle is clear to you, students. Okay, now what if, okay, so such type of LCD is called as transmissive type LCD. Now there is another type of LCD which is called reflective type LCD. Okay, so that's a reflective type LCD. Reflective type LCD. So what's the difference here when compared to the transmissive type? The only difference is that you have an extra layer of a reflector. Okay, so this is the extra layer. The purpose of the reflector is to reflect whatever light falls on it. As simple as that. Further, instead of a vertical polarizer, we have a horizontal light polarizer here. Okay, so that's the major difference. One is the reflector and second one is horizontal light polarizer. But at the right hand side, we have vertical light polarizer itself. Okay, so in the case of transmissive, both the polarizers were vertical. In the case of reflective type LCD, we have a reflector and then one horizontal light polarizer at the left hand side, one vertical light polarizer on the right hand side of this particular structure. Rest all the components are the same. So what happens whenever light is incident? Okay, so whenever light is incident, we are considering no bias case as of now. No bias. Okay, so what happens? The vertical component of the light just enters here, and then because these molecules are misaligned, so the vertical component slowly becomes horizontal component. So this X symbol indicates horizontal component. Okay, now when this horizontal component falls on the horizontal light polarizer, what happens? It has to allow them, right? Okay, if it was vertical, then the horizontal components would have been blocked, but since it is a horizontal light polarizer, the horizontal components will be allowed, which fall on the reflector. The purpose of a reflector is to reflect entire light signals. So the entire horizontal components will be reflected back. Okay, and the same thing will appear here. Okay, so the point is, the entire display appears to be bright. The entire display appears to be bright when there is no bias. However, that is not our purpose, right? Okay, we want the numbers to be displayed. Okay, so for that, let us apply some bias to it. Okay, so if we apply external bias, maybe 2 volts, 5 volts, whatever, what happens? Again, these molecules, they will just align themselves properly, exactly. So the incident light is not at all affected by the orientation of the molecules. Okay, so they will not get shifted with respect to their phase. Here also, at the left hand side, the vertical components will be the same. Okay, however, the polarizer is horizontal light polarizer. So what does that mean? That means this horizontal light polarizer will block will block the vertical light component, vertical light. Okay, so due to which at the human eyesight everything appears to be dark. So these numbers indicate the dark portion. Dark portion. Okay, so I hope the concept is clear for you. Reflective type is exactly the opposite of a transmissive type. Okay, so the same concept is being explained in this theory. You can just go through it as per your convenience, okay, whenever you are free, right? So what did we do so far? We discussed about two different variants of LCD. The first one was dynamic. Okay, so that's a simplistic diagram. So that's a dynamic LCD wherein you have frosted region and the clear region. Okay, without any application of the bias there is absolutely no problem. When you apply external bias, you will get two different regions. The first one is clear region and the second one is frosted region. Then coming to the next type, which is called pneumatic, the twisted. Okay, in the twisted pneumatic LCD case, we have two types, transmissive and the reflective LCDs. Okay, so that was all about the principle of working of a liquid crystal display. Please understand, the material is a organic material, although it consumes low power. However, since it is a chemical material, it eventually over a period of time degrades. Okay, so due to that LCDs have a major drawback. Okay, fine. What about the other points? LCDs are characteristically much slower when compared to LEDs. Okay, because they are of organic material. Organic material. Okay, LCDs typically have response times in the ranges of 100 milliseconds to 300 milliseconds, whereas LEDs are much faster. Their response times are below 100 nanoseconds. So LED, if you want them for switching applications, then LEDs are much more faster when compared to LCDs. Okay, just as a matter of fact, I have just placed two cell phones which use two different types of LCDs. One is the IPS and the second one is Super AMOLED. I hope all students know the difference of it. Okay, when it comes to brands, usually Samsung cell phones, they use Super AMOLED display. Both are LCD types, but their switching is slightly different. IPS stands for in plane switching LCD. Okay, which means the switching is in plane, whereas in Super AMOLED there is an active matrix organic material which is responsible for the display. Okay, now usually Super AMOLED displays are expensive, slightly expensive when compared to IPS LCDs. But the main advantage of Super AMOLED is that it gives some vibrant colors. Okay, if you just observe Samsung cell phones which use Super AMOLED displays, you will observe that the colors are very vibrant. However, IPS, they look slightly dull. Okay, I am talking about only the display, the LCD panel display. They look slightly dull, when compared to a Super AMOLED display. It is because of this reason that the cost of IPS LCD is slightly lesser when compared to Super AMOLED. Super AMOLED displays are slightly costlier and expensive. However, because they use active matrix organic material in their display, they eventually degrade with respect to time. So after 2 to 3 years, Super AMOLED displays start degrading. Okay, so that's that was a rough differentiation between two types of LCD panels which are being used nowadays in almost all the cell phones. Okay, all right. So that was all about LCDs. In our next class, we will discuss about other two terminal devices. Okay. So any doubts here, students? So this session and in our previous session we have discussed about the working principle and the applications of light emitting devices, LEDs, and liquid crystal displays, which are LCDs. Okay. So any doubts, students?